All right, so we are now recording. Thanks everybody for coming to our Google Meet session here. I hope you guys are, adjusting to life and getting daily emails and stuff like that in our virtual distance learning here. But what I've opened it up to the group to do is you guys can ask me whatever questions you might have. I'll kind of work them out on the pad over here. I can write you a really quick message. I can say, hi, pre-calc. And I miss you. Okay, which is very true. I actually really do miss you guys. If you ask me I guess, if there is a silver lining to this, it's, that you get to spend more time with family. And if you ask me what's the worst time about all of this, it's maybe the same response. So I love my kids. It's been good to have some extra time with them, but at the same token, it can be a challenge at times. So I really do miss being with you guys each and every day. And okay, we'll open it up to questions. If you've got a question, go for it.
Okay, I was doing the review.
Okay.
And I was trying number 9, and I got it. I tried to find angle A, and I got it undefined or like error, whatever it is.
Oh, okay. Yeah, let's work on that then. So number 9, given the 3 sides of the triangle, that one?
Yeah.
Okay, so for number 9 on the review, the 3 sides of the triangle ABC, we have that little a is 27, little b is 31, and little c is 43. So when you're given side, side, side in a triangle, side, 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 immediately I hope makes you guys jump to law of cosines. I've used that abbreviation a few times, I think, in some of the videos and notes, so hopefully that's made sense when I write LOC for law of cosines. And if I were trying to find the largest angle, is that what it said? The largest angle is going to be the one across from the largest side. So we're trying to find angle C. And if I'm trying to find angle C, then your law of cosine should start with little c squared, and that would equal a squared plus b squared minus 2ab cosine of, at the end, this angle will always match this side that's across from it. Now, if you're getting an undefined on the calculator, I think I probably know where it's coming from, but let's check it out. So I would plug in little c is 43, so 43 squared equals, then little a is 27 squared plus 31 squared minus 2 times 27 times 31. And at the end, we put cosine of angle C. So that's kind of what that substitution would look like. Alexis, is that good so far? I think this is Alexis's question.
Yeah, I just didn't know how to find the other possibilities of it.
Okay, gotcha. So for law of cosines, they'll tell you that there won't be any other possibilities like there is for that ambiguous case of law of sines. So that's actually a good point to bring up as well. But let me start typing some of this into the calculator. So we get 43 squared, which is 1,849. What I wind up doing on the right side, and I probably only modeled this once in a video, is I sort of make 2 groups here. So I can do the 27 squared plus the 31 squared, and that comes out to be 1,690. And then on the other hand, if I do 2 times 27 times 31, that's going to be negative 1,674 cosine C. And it's really tempting, I think, at this stage in the game to subtract those numbers, because it's like, hey, I'm doing subtraction right here. But the only thing is that 1674 is attached to cos C through multiplication. So if you think about PEMDAS real quick, I was actually talking with some other teachers, and they were saying something called GEMS. I don't know if you guys have ever heard of that, but I've just always heard PEMDAS. I don't even know what GEMS would stand for. But if anybody on the chat knows what GEMS means, apparently GEMS is another version of PEMDAS. Maybe chime in or type it into the chat, because I've never heard of GEMS, but I'm sure it's something like grouping, exponents, multiplies, I have no idea, actually. But anyway, so if I'm following PEMDAS, we got to think about the multiplication before I can subtract those. So since I can't subtract them, I'm actually going to subtract the 1690 to this side. So 1849 Sounds like an important historical year. I don't know what happened then, but minus 1690 is 159. That equals negative 1674 cos C. Another thing that students tend to lose is that negative sign that's attached to the 1674. So make sure you kind of carry that down into this step right here. Dividing both sides by negative 1,674, it's going to give us cos C equals definitely a not nice looking decimal, but that's okay. So if I'm doing this correctly, that looks good. Negative 0.09498 dot dot dot. The last step is we're going to do cos inverse of this answer. And if I do cos inverse of that, finally we're going to get 95 degrees as the final answer. And as a quick check, 95 degrees would have to be the largest angle in the triangle. You know, if you have an angle that's 90 or larger, it's definitely the biggest in there. So that's the work and what law of cosines might look like to find an angle in a triangle. The follow-up to that is find the area of the triangle. Does anyone want me to do that?
Yes.
There's a yes for area of a triangle. Okay. So this was the part A of that question. Part B is area. So I think the easiest area formula to choose is that the area is 1/2. I'm going to rate it kind of in general. You don't have to have AB sine C. Like, it doesn't really matter how the triangle is labeled with A's, B's, and C's. Just know that this would be a side angle side case. So if you have two sides and then the angle in between those sides, this is a version of the area of a triangle formula. And then beyond that, if you have all three sides of a triangle, which is what we initially started with, we can find the area using what's called Heron's formula, which is when you calculate S, it's called the semi-perimeter. You would multiply that by S minus A, S minus B, and S minus C, and then finally take the square root of all that. So this would be if you had side, 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 which we actually also have. Out of these two, if I can choose between them equally, I kind of like the first option. If you guys want me to show you what the second option looks like, I'd be happy to do that. But I'll show you the first option. If I look back to the picture, the side angle side is, oops, actually chose the only side that I didn't want to choose. It's the two sides that surround angle C. So I've highlighted that in orange for a reason, because I didn't want to choose that side, of course. I want to choose the two sides that I'm highlighting in green to make this side angle side. Okay, because we just found angle C was 95 degrees. So when I do 1/2 the two sides and sine of the angle at the end, it's going to be 1/2 of the 27 and the 31, and then sine of 95. And if I type that in the calculator quick, 0.5 of 27, 31, and sine 95. Make sure you're in degree mode, by the way, when you're doing this stuff. Is 416. Doesn't say to round anywhere. I'll go to the nearest square unit, 417. And this would be units squared. Now, I'm sure I mentioned in my video, but don't think I didn't take my pens home with me, guys. I got a really nice assortment going here. So if you have any color requests, you just shout them out and it's coming your way. So, all right, so that was all of number 9. Anybody else have a question on the review or something else?
Could you maybe go through 6 on the review?
I sure can. All right, let's check out number 6.
You're seeing Ashley.
Ow. Oh, fuck.
Okay. So if you guys, once you ask your question, maybe just mute yourselves this way. I think what will happen is I actually can't see any of you right now because I'm just looking at my pad on the screen. But I think when I go to show this video later, if something happens with noise in your background, it will focus on you instead of what I'm writing down. So just as a quick thought, I think that's what will happen is if your microphone is on while I'm talking and it kind of cuts to you, people later on might miss some of this. Not a big deal, but just a quick thought. Okay, so number 6 is a good question because that's that shaded area question. This is actually called the area of a shaded segment. I'll try and actually just redraw. Oh boy, that was not a great circle. Don't judge me too harshly, guys. All right. It's like a little guy with some hair up here. Okay. And from the center of the circle, this is what's labeled here. We have that this is 77 degrees. We have this segment drawn across the bottom. That's called a chord of a circle. Don't worry too much about it. This is shaded in, and the radius is 6 inches. So this is actually one of the tougher areas to find because we have to calculate 2 areas to get that. And I'll try and, I don't know if I'll do a good job showing you this, but if you calculate the whole sector area, so the sector is the whole piece of the pie that I'm cutting out of this circle, and then I subtract the area of the triangle from that sector, if I do that, then we'll wind up getting the area that's left is this shaded segment down here. Okay. So in general, when you're finding an area like this, it's the area of the sector minus the area of the triangle. Okay. So area of a sector, what was the formula for that? It was 1/2 r squared theta. If we were actually testing on this unit in class, these would be formulas that you would be expected to remember. However, when you're working on the review that you guys submit to me, you can look back through the notes to make sure you have the formulas correct. Make sure that when you plug in that theta, it has to be in radians for sure. Okay. Then the area of a triangle, we actually just did that, so that's kind of nice. I'm going to use the 1/2 AB sine C formula. Now, that angle that I plug in for C does not have to be in radians. Does not have to be at all. So the fact that it's 77 degrees is totally fine. The only thing I have to worry about radians is theta in this case. So I'm going to do, first of all, 1/2 of the radius, which is 6 squared. So we can quickly convert 77 degrees to radians by multiplying by pi over 180. I don't think that reduces, but to be honest, even if it did reduce, it wouldn't matter. You wouldn't have to reduce this because I'm just going to probably get to the calculator. And yeah, it does say in the question, find to the nearest tenth. Minus 1/2 of, well, if we have side angle side going on here, right, because this would also be 6 inches in that radius. So it would be 1/2 of 6 times 6. And then at the end, sine 77. So what mode do I have to be in when I type this in? I have to be in degree mode. Because when I do sine of a degree angle, the calculator has to be in degree mode. If this angle was already given in radians up here, like let's say it was pi over 3, something kind of nice. Well, that would have been easy because I could have just plugged in pi over 3 in this spot. At the end, could I have written sine of pi over 3? Absolutely. But if I wanted to type that in the calculator, you would have to be in radian mode. So just a quick thought about that, what mode should we be in? You got to be in degree to do something like this. Okay. So we got 0.5 times 6 squared, and you could do it all at once, times 77 pi over 180 when I convert that, minus the triangle area, 0.5 of, it really is 6 squared again, right? I'll keep it separate, 6 times 6, and then sine 77. Oops, I did not do that correct, I don't think. Yeah, I only did 7 degrees. Hold on. Sine 77, I'll fix that to get that the area to the near, the 10th place is 6.7 is what that would round to. So since we're dealing with inches, we'll say we've got 6.7 square inches. I really don't mind going through the full solution with you guys. There might be a couple in the future that if you ask me, I might say, all right, am I okay to stop here? But, since we've really been doing all of this mostly on our own with, I hope, the help of those videos that we've done, I really want to give you guys the best opportunity to, get a good grasp on this stuff. So I think that might have been Addie who said that, or whoever chimed in there, but is that okay for this one, area of a segment?
Yeah, that's great. Thank you.
Okay, perfect. So what else can I assist with? That was number 6. I'm going to label that for people later on. Other questions you guys have?
Could you go through number 14, please? It's
Sure.
The very thing is like messing me up.
Yes. I do think bearings, the toughest part about this probably unit in general is deciphering those word problems that have bearings in them. And then once you draw the picture, I would hope that with some practice that we feel really confident using law of sines or cosines, because that's always what it's going to be in those scenarios. But yeah, let's take a look at number 14. So starting at point A, a ship sails 18.5 kilometers on a bearing of 189. And then it turns and sails 47.8 kilometers on a bearing of 317. Find the distance from the ship to point A to the nearest tenth. Okay, so taking a look at this one, we're going to start initially sailing on a bearing of 189. So I'm going to say, let's say the ship starts here. And are we starting at point A? Yeah, so this is point A. All right. 189 degrees, what does that bearing look like? So the first thing you're going to do is, since there's not two directions given to us, is draw that line directly north. And then from there, you're going to rotate clockwise 189 degrees. So this would be 90, 180 would be down here. You're really just going to wind up going 9 degrees past this line that's due south. So if I kind of rotate around this way, we travel in this direction, and it says we do that for 18.5 kilometers. And then once we travel that distance, then it stops, and it winds up turning and sailing on a bearing of 317 degrees for 47.8 kilometers. So once I stop there to sketch the new bearing of 317, draw that line due north again. And what we're going to do is we're going to go 317 degrees. So again, this is 90, 180, 270. 317 would be, I guess, what would that be? 30, like 47 degrees beyond this line here. That actually might be important information later. Okay. And whoa, why did I go crazy and extend all the way up here? Well, I'm not too crazy, but the distance that we're given there is 47.8 kilometers. So I just wanted to make that pretty distinct to show, hey, when I sail in this direction, that this length is definitely longer than the original. I don't wind up being in the same east-west line as where point A was. So the question says, well, how far is the ship from where it started at point A? So that's what I'm trying to find the distance of right there. Okay. If I look at this, again, this is definitely a tougher one to set up. So I'm glad that you asked this one, because the picture is really where it's at. So we have these two sides of the triangle. That's good information. You really can't get too far without most likely knowing an angle on the inside. And if I have two sides, I think we're kind of hoping that we know the angle that's in between those two sides. And I'll see if I can convince you that the angle, this tiny little angle right here, is 9 degrees. And how might I convince you that that's 9 degrees? Remember before when I was drawing the 189? And I said, oh, it just goes 9 degrees past that south line. Well, that line that's due south and this line that's due north are parallel. So these are actually these alternate interior angles. So these would both be 9 degrees. So that was probably a little bit of a tough connection, but now that you're seeing it, I hope it makes sense. The other part of that angle is, what's on this side. And if I look at that, well, that's the whole bearing was what, 317? So wouldn't that have completed 360, that other part of the angle? If you do 360 minus the 317, that leaves you with 43 degrees on this side, which makes the total angle, 43 plus 9, 52 degrees. So not only was the initial bearings probably a little bit of a tough sketch there, but then finding that entire angle, there's definitely a lot of logic we have to use to get there. But now that we have side angle side is the other case for law of cosines again. So side angle side, those are the two law of cosines cases. The setup for something like this, it's a little bit easier to use law of cosines with finding a side length. So we're going to find side x. So it actually would start with x squared equals. The order of the other two sides doesn't really matter. 18.5 squared plus 47.8 squared. minus 2 times 18.5 times 47.8. And then cos of the angle in between, 52 degrees, goes at the end. Okay. The thing that I like about law of cosines in this case is that you get to type all that into the calculator at once. So let's see if I can do this carefully. 18.5 squared plus 47.8 squared minus 2 times both of those. Cos 52, I'm still in degree mode. I got that that's 780,897 ... Square root, that's actually not the right number. Man, you guys should have chimed in and stopped me here. I went too fast. Okay. It sounds a little bit large to me. I was willing to go with it, but I actually forgot a plus sign over here. Oops. Yeah, and originally I had those things multiplied, which is why I was getting such a big number. But, all right, this is going to be a little bit better, I think. Yeah, 1538.23. Square root of that is 39.2. So the distance that the boat is from where it originally started is that many kilometers. Okay. Sorry if I've turned sideways in the midst of doing all this here, guys, but I'll move that down a little bit. Okay, really good question. And again, bearings, it's all about that picture setup. Once you have the picture set up, maybe you have to do a little bit more investigative work to find some of these angles and sides and stuff like that. But hopefully the pictures with a little bit more practice get easier for you guys to set up. Okay, other questions that you want to ask about?
I don't have a question on like the actual review.
Okay.
But in your email you said to send you the completed review by the end of the day Friday. So do we just like send you pictures of it, or?
I'm thinking that's going to be the easiest way for you guys to get it to me. I mean, I actually don't have a printer at home, so I wouldn't be able to scan it myself and send stuff to you guys that way. If you are able to, yeah, I would like you to do exactly that. Take pictures of the review, try and make them as clear as possible so that I can see them when they get sent in the email. And then I'll just kind of take a look and make sure you've completed it and kind of go from there. So.
Okay, thank you.
Yes, thanks for clearing that up.
Do you think we could go over number 11?
I think we could. Yes, we certainly can. 11, the consecutive sides of a parallelogram. Oh man, those parallelograms, they're always sneaking in here. Okay, let's see. For number 11, we have, try and draw my best parallelogram here. It's not so bad. Okay, so what do we know about this parallelogram in number 11? The consecutive sides are 8 and 14. So here they are. If you want to right away, just to kind of start completing the diagram, we know opposite sides of a parallelogram are congruent, so you can label the others as 8 and 14 as well. And the measure of one angle is 70. Depending on how you decide to tilt your parallelogram, just make sure that whatever the acute angle is, that you label that as 70, which would make this opposite angle up here 70 as well. And what do we want to know? What is the measure of the shorter diagonal to the nearest tenth? Well, I guess we're kind of in luck here, because I'll tell you the shorter diagonal is going to be the one that connects across this way. Okay, so if you draw on both diagonals, I hope that based on how you've drawn your picture, you would clearly see that one's short and then the other's definitely longer than the other. If it's said to find the longer diagonal, just to kind of play devil's advocate for a second here, guys, the longer diagonal would have been this one. The question that I did in the notes like this, that diagonal doesn't split the 70 down here. It wouldn't be 35, 35. So what you would have had to have done is find this angle up here, which is the supplement of 70. So you would have had to have known that that was 110 to kind of proceed and find this diagonal length. But in this scenario, since I didn't even have to go that far with it, to find this, sometimes maybe even labeling the whole picture makes things a little bit confusing. If I kind of cover up this side of it, we have a triangle and we have side angle side. So if we have side angle side in a triangle, it's going to be law of cosines again. So similar to the one that we just did, this one's going to say x squared equals, and you would do 8 squared plus 14 squared minus 2 times 8 times 14, and then cos 70. Okay. Morgan, thanks for letting me know. Sorry that I scheduled this at the same time as your bio meeting. I have no idea what your other teachers are scheduling. We don't have a good way to figure that out yet. Thanks for joining in, girls. If you want to check out the other stuff that we do, I'll post the video recording of this on the website later. Thanks for joining today, though. This you would just type in the calc then, Sean, and then square root of it would get you the answer. Is that okay for the first part of it, Sean?
Yeah, that's fine. I can just do that.
Okay. So part B, the area part, would be that, again, if you just kind of think of this triangle first up here, this triangle has the same area. So with that side angle side setup, I would use this formula for area. I don't typically use that other formula I wrote down too often, that Heron's formula, that when you know side, side, side. It's useful if that's what you're given and you don't know any angles at all. But yeah, this one I would probably use this formula. So I would sub in the two sides of 8 and 14. At the end, we'd put sine of 70. And if I double that, that would be the area of the parallelogram. So sometimes students ask, instead of actually doubling this answer, could we just take out the 1/2, right? Because doubling 1/2 would make that a 1. And the answer is yes. So you could actually just do AB sine C if you're finding the area of a parallelogram.
All right, thank you.
Yeah, you got it. Anything else I can assist with for those people that are left?
I just have a quick question. Will you be posting like the answers to this at some point, or?
Yes. So that's a great question, Addie. I think my plan is once I get the work from everybody to see that everyone's put in a solid effort to completing the review, that I will then send out an answer key so you guys can start checking some of that stuff before we move on to the next unit. So, at this point, we really don't know. We know that we're out till next Wednesday, and that's all we know. So we're going to start, everything beyond trig, which will be very different. We're going to start doing systems of equations and get into a topic called matrices. So you guys will see that I'll start posting some of that stuff at the beginning of next week. But yeah, if I don't get a review from you, don't be surprised if I reach out to you guys and say like, hey, you didn't send me anything. Are you still working? Because clearly I can't really grade you on anything right now. I'm guessing your other teachers have gone with a similar train of thought on that, it's a little tough for me to hold you accountable and give you specific grades for this stuff. But on that same note, I really want to make sure you're taking this time seriously and not just saying, yeah, that was a good couple weeks off. And, if we're back when I hope we get back, this stuff might be on a final exam someday. So I want to make sure that we're really putting in some effort in getting these questions done. So, and I don't have any concerns about the people who showed up here today, but there's some people I haven't heard from yet at all. So definitely make that effort, guys. And the review's already up there, right? Review's already posted. So get this to me at some point by the end of the day tomorrow would be great. I'm definitely willing to take a couple more questions if we've got them. If there are no more questions from the group right now, I actually probably will do number 3, just at least the setup of it. Because I'll tell you, number 3 is most likely, if we were in class, one that I would have done with our group anyway. So anything else before I do number 3? Okay, so number 3 is a bearings question. And it's about a plane flying on different bearings. So, a lot of times you'll see bearings questions about ships out on the water flying on certain bearing or sailing on certain bearings. But certainly planes might also travel in directions that are given in a bearing format. So for number 3, and again, maybe I might only set up the picture. It says from point A to point C, the bearing is south 52 degrees east. And from point A to point B, it's north 84 degrees east. The thing that I think that makes this one tough is that usually you only know those 2 bearings, or it just gives you 2 bearings, but there's a third bearing given, that from B to C, the bearing is south 38 degrees west. Okay, so let's see if I can start sketching an idea of what's going on here. I'm going to put point A over here. The reason why I'm choosing point A on the left side of the page is that the bearings to points B and C is that they are each in an easterly direction. So the bearing to point C is south 52 degrees east. So 52 degrees might be an angle like that. So here's going to get me to C. And then the bearing from A to point B is north 84 degrees east. So that's a pretty severe bearing there, right? I mean, 84 degrees east is almost directly east. So 84 degrees coming around this way. Okay. And the last thing I want you to do is, okay, if here's point B, let's say, if I stop there, the last thing I want you to think about is from point B to point C, you just have to make sure you don't extend point C too far, because from B to C, the bearing is southwest. So if I made C come all the way down here, let's say, then it would have been southeast of B. So in terms of the diagram, I think we have to read that a few times to know that if I go south and then I go west 38 degrees, that's the bearing of C from point B. And then we know a couple of other pieces of information. A plane that's going 250 miles per hour takes 2.4 hours to get from A to B. So 250 times 2.4 hours is 600. So that's this distance here. And then what else do we know? Something else? No. Okay. Find the distance from A to C is what we want to do. So actually, in the end, I want to find this side right here. Okay. If you look at the diagram right now as it is, we don't have a ton of information here, right? So we have just one side of the triangle, and then we have no angles on the inside. So it's pretty bare as we're looking at this. But the easiest angle to find initially, in my opinion, is probably this one right here. Because if you look at this straight line that goes through point A, that north-south bearing directions, this whole half circle would have to equal 180. So I would do 180 minus the 84 and minus the 52 to get 44 degrees here. And I think the other tricky part about this is that I think the next thing I'm going to do is find the interior at vertex B over here. But what we have to know is that we know this whole angle that goes from segment AB to the line due south, that whole thing is 84 because it's alternate interior with this over here. So if that whole thing is 84, 84 minus 38 is 46 degrees. And if I'm doing the math correctly in my head, is this a right angle, guys? 44 plus 46? That's 90 degrees. So this actually is a big old right angle then. And wow, look how accurate my picture was. I didn't even remember that about this one, but that's 90 degrees down there. If it's a 90-degree angle, you can certainly do SOHCAHTOA, but that really hasn't been a focus much in this unit. So to find side X, what I might expect to see is maybe some law of sines. So just because we haven't done law of sines at all today, law of sines would look like this. You would do 600 over sine of 90. That would equal X over sine 46. And then if you cross multiply X times sine 90, by the way, sine of 90 is 1, so that's just going to be X. So you're going to wind up getting 600 times sine 46. If we didn't know sine of 90 was 1, all I would have done to get X alone is divided over, which, you know, wouldn't have changed 600 sine 46. So that distance is 431.6. So we'll say about 432. And this was a distance in kilometers, maybe? Nope, miles. Okay. I think that number 3 was probably the toughest bearing question on the entire review. So I hope that going over that one helps to make some of the others not seem so bad. The one thing that I will say is that the other bearing questions that we have not done, you can find ones very similar to them in the bearings lesson. So if you guys take a look back at the lesson that was posted at the end of Trig Part 6, I promise there's questions just like the others. This one I thought was probably a little bit different and unique. So definitely wanted to kind of touch base on that one. But I'll open it up to you one more time, see if you guys have any last minute questions here. I'm not seeing any. So let's see. Can I pop and see your faces? Maybe. Let's see if I know how to do that. Oh, there I am. Okay. I don't know if you guys can see me, but I can see myself. So I'm guessing that means you can see me. Okay. All right. If there are no other questions, we'll kind of end it there for today. I'll stop the recording in a second and I'll post this video on the website later. Thanks so much for coming, though, guys. I really do appreciate you taking the time and the effort. And like I was saying earlier, I'll at some point give you an outlook as to what next week is going to look like, what the topics are, and give you a little bit of an idea. We'll probably have another Google Meet session, let's say middle to end of next week, to check in again and see if you have any questions. All right. All right, remember, us math teachers, we put the fun in the functions each and every single day. So really good seeing you guys. Hope to catch up with you soon. If you need anything, of course, definitely send me an email. All right. Gonna stop recording.